In this video, we're going to look at the cosine rule. The cosine rule allows you to work out the angle of any triangle, so long as you know the three lengths. So if you know the three lengths, then you will know this, you will know this, you will know this, you will know this, you will know this. Therefore, you can work backwards to find out this angle here. You see, with a right angle triangle, it's always easy to find the angle. But the cosine rule works for all triangles, so long as you know the three lengths. So let's look at this triangle. At the moment, it's slanted. There is an associated angle here. Well, you can always rotate it. You can always You can always rotate it so that it lies flat on the table. So bear with me. So you can always rotate it so that it lies flat on the table like this. So that it lies flat. Hang on, bear with me. You can always rotate it so that it lies flat on the table, and then you would split this down the middle. So now you've got two triangles. You've got this right angle triangle here, and then you've got this right angle triangle over here. Well, the idea behind the cosine rule is that we would use this triangle here to work out the height of this. So the height of this is really us using this triangle. It would be sine. So don't forget this is sine here. So sine it would be a sine theta. The height would be a sine theta. And using this triangle, we can work out this length here. It would be a cos theta. So the idea behind the cosine rule is that we would use this triangle to obtain the height and to obtain, well, we know x here, to obtain this length. And then we would look at this triangle to use Pythagoras. So we would use Pythagoras on this small triangle here. You see what I mean later. So let's start from the beginning. So we've got our triangle. Draw a line straight down the middle. So now this height here will be given by, well, the height here, well, we would use this small triangle here. This would be sine, so the height would be a sine theta. And then now look at this small triangle here. Use Pythagoras on this small triangle. So it would be a squared. It would be c squared. So c squared. That would be the height squared. Well, we've just worked out the height. Square this. It would be a squared sine squared. And then now square this. Well, don't forget x. This x here is really, hang on. This x here is really, don't forget x is a cos theta by looking at this triangle here, because a cos theta. So now, so this is your x here. Put that into here. So you will have b, which is this b here, minus, which is this minus here, and then your x will be this thing here. So that will be this bit here. So don't forget that. So that's the whole length there, and then we would square it. So we would square the whole thing. So going back to here, going back to here, looking at this small triangle, using Pythagoras, c squared, that's this bit, and then the height squared, so that's this bit here, and then this length here is given by this bubble here, but then we've got to square it. So that will then take us to here. So now multiply this out. That will then give us this whole thing here. So this thing here is this thing here. So now you should spot that you've got squared, sine squared, cos squared. So you should be thinking about this. Okay, sine squared plus cos squared would be 1. So group these two together. That would be a squared, and then that will then give you this. You've got your b squared, and then minus this thing here. So now this thing here is 1. So it would be a squared, and then you've got your b squared, and then you've got your minus whatever here. That's what we had right from the start. So this is your cosine rule. Okay.